Assalamu alaikum warahmatullahi wabarakatuh. We are discussing first order linear differential equations, and we have the last lecture we have seen how to solve the differential equation. Now we have a very special form. We have the Bernoulli equation. This is not linear, but we can make it linear. It has a particular form, and we have just written here in the definition of that one, that we have dy by dx plus pxy plus qx. Here we have y to power n, and we say this n is not equal to 0 and n is not equal to 1. When equal to 0, y equal to 0 is 1, then we are having the standard first order linear differential equation. When n equal to 1, we can just shift it to the right hand side and get px plus qx, y equal to 0. That's again standard linear differential equation form, first order linear differential form. And we have discussed this on how to solve it. I will show you again today that how we can apply that one to solve the Bernoulli. So the Bernoulli equation, what we do, we shift it to the first order linear differential equation. And then we can solve it as we have done in the beginning, that we have the equation, homogeneous equation. We transfer this equation to the form that is our homogeneous equation to the equation of the variable separable form, and then we solve it. And then we are having the equations which are not exact, and that's why we just find the integrating factor, multiply the equation with the integrated factor, we make it exact, and then we solve it. Similarly, these equations, the standard differential equation for the Bernoulli equation, where y is on the right hand side, and here this having power n, and this n is not 0 and is not equal to 1. We are going to discuss solution for this one. As I said, we will make it linear. That's our method of solving the Bernoulli equation. I give you the step for this one, for the method. We just make this coefficient 1. So multiply this by the equation by y to power n. We get here y to power minus n, dy by dx. We get here plus px y into y to power minus n is equal to qx into y to power n into y to power minus n. We can see it here, y to power n, y to power minus n, they become y to power 0, that's equal to 1. And here y to power n, y, we get 1 minus n. So you can rewrite this one. We get y to power minus n dy by dx plus we get here p of x y to power 1 minus n is equal to q of x. So this is one form which I just developed by multiplying y to power n. This I write my equation 2. Now in this equation 2, I change this y to power 1 minus n to w. I make the transformation w is equal to y to power 1 minus n. I can write my here dw by dx. My dw by dx is equal to 1 minus n. Then we get here dy by dx, we use the power rule, into y to power 1 minus n minus 1. We simplify this one and we can write the value for this one. We write here dw by dx is equal to, we have 1 minus n, get here dy by dx, and we get here y to power minus n. We open this one, this minus n and 1 is cancelled. So I have here two substitutions. This is my equation 2. I get here this as number 3, and this is my number 4. Now we substitute this number 3 and number 4 in my equation 2. I can rewrite this one further, that I can just divide this one by 1 minus n, so get the value of dy by dx y to power n. So I can write here my dy by dx y to power minus n is equal to 1 over 1 minus n dw by dx. Now my substitution is ready. I replace this y to power minus n dy by dx by this value. This is 1 upon n, 1 upon 1 minus n dw by dx, plus here. Now I have the value of px y to power 1 minus n, y to power 1 minus n is equal to w. So I change this one by w. So I get here px into w, and the right hand side I am already having here only q of x. So I write here q of x. Now I am very near to the form of first order linear differential equation. In first order linear differential we having the coefficient must be equal to 1. So I multiply this equation by 1 minus n. So I get here dw by dx plus 1 minus n p of x w is equal to 1 minus n q of x. So if I say this is my standard form of first order linear differential equation, that will be correct. And this is my equation number 4, 5. We have here already 4. We have equation 5. So in equation 5, this first order linear differential equation, and I can find the integrating factor. To find the integrating factor, I take this one, the 1 minus n w, and we take p of x, and the coefficient of w is this one, and we can write the integrating factor. And with the help of integrating factor, we can write our solution. So we write here our mu of x is equal to integral e to power 1 minus n p of x dx. This is my integrated factor, and then I multiply by the integrated factor and get my solution. And my solution in this case will be equal to d by dx of the integrated factor mu of x into w is equal to the integrated factor, this mu of x, into my right hand side is 1 minus n into q of x. So that's, I integrate it and I will get my solution. I take an example to explain this application, how we can solve the Bernoulli equation. We are given here the Bernoulli equation, solve the Bernoulli equation. Our differential equation given to us is dy by dx plus y is equal to x y to power 3. The solution of this one, we can get here our n is equal to 3. So this is our Bernoulli equation. So we multiply y to power minus 3, we get here y to power minus 3 dy by dx. We are having here plus y into y to power minus 3 is equal to x y to power 3 into y to power minus 3. So we just simplify this one and we can get here the value is equal to y to power minus 3 into dy by dx, and we are having here plus y to power minus 2 is equal to x. This is my equation, as I mentioned below in my equation 3, that I just multiply minus y to power n, we get this equation. So we are having here our p of x is 1 here, and we having y to power n. This value will become our w. So as we met here, we get w is equal to 1 minus n. I say w, we can substitute it here also, and this will become minus 2. Or we take this one as w, we get here minus 2, so we can just take this one as our w, this value always, when we make this side independent of y, and then this is my w. And now I can write my dw by dx. My dw by dx is equal to minus 2 y to power minus 3 dy by dx. Now this is my substitution, and I substitute this in my equation, but I need here minus 2. So here what I did, I substitute at the end, I multiply 1 minus n. I multiply it here. I multiply because I need here minus 2. I multiply by minus 2. I get in minus 2 y to power minus 3 dy by dx. You get plus, I multiply minus 2 y to power minus 2 is equal to x. I multiply here by minus 2. Now I substitute the values. This is my dw by dx plus, we get here minus 2w, and getting minus 2x. So this is my first order linear differential equation in w. So I can find my p of x. My p of x is equal to minus 2, and my q of x is equal to minus 2x. Now I use the method for the solving the differential equation by first order linear differential equation, and we can solve it. To find the integrated factor, we write here mu of x is equal to e to power integral p of x dx. Now we can see what's our p of x, e to power integral minus 2 into dx. So we just integrate it, we take minus 2 common, and we get here e to power minus 2x our integrating factor. So this is our integrating factor we get. We can write my solution. We can get here d by dx, integrating factor into w is equal to integrated factor into q of x. Our q of x is minus 2x into e to power minus 2x. Now we integrate both the sides and we'll get the solution. Our solution will be e to power minus 2x w is equal to integral minus 2 take out because the constant, we get x e to power minus 2x dx. So we integrate it, we get our solution. So to integrate that one, I told you that's easy way to solving this one. We take the long integration, we get here x, and we having e to power minus 2x. So I take derivative of this one, derivative of this one is 1. Integral of this one is e to power minus 2x over minus 2. Then derivative of this one is 0. Integral of this one is e to power minus 2x. Minus 2 is 4. This here multiply plus, multiplying here by minus. So I can write my solution. My solution is e to power minus 2x. W is equal to minus 2 into integral of x e to power minus 2x dx. We get here this equal to minus x e to power minus 2x over 2. Then we get here minus, because this is here is minus, this was plus, remain minus, and here become minus 1 by 4 e to power minus 2x plus constant c. Multiply by minus 2, we get here e to power minus 2x. W is equal to minus plus, 2 is cancelled 2, we get x e to power minus 2x. Then this minus plus, and this become 1 by 2 e to power minus 2x plus constant c. Now, want to find the coefficient without e to power minus 2x, we divide by e to power 2x, we get here w is equal to x e to power minus 2x over e to power minus 2x plus 1 by 2 e to power minus 2x over e to power minus 2x plus c over e to power minus 2x. We simplify this one, we get here w is equal to x plus 1 by 2 plus c e to power 2x. But what's my w? What's my w? My w was here y to power minus 2. So I can write my solution that y to power minus 2 is equal to x plus 1 by 2 plus c e to power 2x. This is solution of my differential equation. You can write this instead of 1 power 2 get 1 power y square is equal to x plus 1 by 2 c e to power 2x is general solution of Bernoulli equation. So our equation was nonlinear. We solved this one and we changed this one, as I said. We change our equation to the first order linear differential equation. This is the first order linear differential equation, and we can solve this one by the method of the integrating factor. This is my integrating factor. Now we use this integrating factor, we write our solution in this form, integrate it, and we, as I mentioned you from the beginning, that we need the formulas for the integration. We need the techniques of integration, because all the time when you're going to solve the differential equation, you have to do 1 or 2 times. Definitely the integration in your procedure, especially when we are discussing the first order linear differential equation. So you must master the formulas, you must master the techniques of integration. Then again, I would like to mention it, as we are having the series of lectures on this one. This was 14th lecture, 13th lecture was saying we'll continue this one. This will be the last lecture for this chapter. We have the playlist, and we're putting this in the playlist in our channel. We are putting you can take other lecture from there. Number 1, number 2, like this one, subscribe it, and press the bell icon so that you can get the notification for the videos which we are just preparing for the coming lectures also. And you can take all this one in the from the our playlist, number 1, number 2. I am putting my notes in the description, and you can just take the link from the description and you can copy the notes also. That contains more examples and then contains more exercise you can do. And you can master this on mathematics by doing exercise, not by reading, not by listening videos, not by looking on the videos. No, you have to solve the problems. When you solve the problems, then your brain is working with you, and then you can know how much you understand it and how much you can reproduce this one. The main benefit of these videos is that you can replay it. You can replay it not 1, 2, 3 times till you understand that one. So we wish you all the best, Go accordingly, inshallah you will learn more.